All right, let's look at your 3.1.1 E notes. So start off by looking at our vertical dilations given a graph. So the parent function here is the black V. It's y equals absolute value of x. Our first example is a dilation with a stretch factor of 2. So we're familiar with this from our geometry days, right? We were looking at dilations with triangles and other shapes using a scale factor greater than 1. And what happened when you had a scale factor greater than 1, took that shape and it enlarged it. And then we had where the scale factor was between 0 and 1. And what happened with the geometry of the shape? It shrunk it and made it smaller. So we're going to be using that same idea here, but we're just going to be talking about the vertical dilation of our V. So our parent function, again, is the one that's in black. This pink one is going to be where we're using a scale factor of 2. So that is going to be absolute value of 2 is bigger than 1. So what happens is it's going to take that V, it's going to stretch it. So for every value of x, it's going to go up faster than the original parent graph. So you go over 1, we go up 1 for the parent graph. But for my one with the scale factor of 2, we go over 1, we go up 2. When I go over 2, I usually go up 2. But my scale factor is 2, so I go over 2, I go up 4, all the way to this point here. I go over 3, I usually just go up 3, but on my dilated figure, I go up all the way to 6. So what's the coordinate notation that maps those points? Well, your original xy goes to x, comma, 2y. So your x stays the same, and you take your original y value on your parent graph, and you multiply it by 2. And that gets us to the new point. All right. Compression. So if we have a scale factor that's less than 1, or between 0 and 1, it's going to shrink, or in this case, it's going to compress the V. It's going to make the V fatter, because now for every value of x, you're not going up as much, you're going up less. So in this example, our scale factor is 1/2. So when I go over 1, instead of going up 1, I only go up 1/2. When I go over 2, instead of going up 2, I go up 1. When I go over 4, instead of going up 4, I'm only going to go up 2. So again, the mapping is x comma y goes to x comma 1/2 y. All right, now let's look at equations. So the a value, if the absolute value of a is bigger than 1, then it's going to be a vertical stretch. If the a value is 1 or -1, then there's no dilation in that situation. So here's our example: y equals 2 times the absolute value of x minus 7 plus 3. We know that has a vertical stretch. The scale factor is 2. Y equals -4 times the absolute value of x minus 7 plus 3. So we know that has a vertical scale factor. The scale factor is 4, stretched. We know the negative sign makes it reflect over the x-axis. So in that case, it also opens down. Example 2, our a value here, y equals 1/2, absolute value x minus 7 plus 3. A value is 1/2, so that's between 0 and 1. Therefore, it is a dilation that is a vertical compression. And then we have our next example, y equals -1/3 times the absolute value of x minus 7 plus 3. A value is -1/3. So the scale factor is 1/3. The negative sign means it reflects over the x-axis. So it is going to be compressed, but it's going to open down. And that's it.